So see, image sampling and quantization. So basically, why do we need something like this? Just now we have seen that we are using sensors to capture the image. What was the output of sensors? It was voltage waveform, correct? So the voltage waveform is in analog. What are we doing? Digital image processing. So there has to be something that will convert your analog image into a digital image. And that process is nothing but image sampling and quantization. Okay? Now, the output of most sensors is a continuous voltage waveform whose amplitude and the spiral behavior are related to the physical phenomena being sensed. So अब जो इमेज कैप्चर करना चाहते हो उसका जो भी इंफॉर्मेशन होता है वो उसके वोल्टेज वेवफॉर्म के एम्पलीट्यूड एंड स्पाइरल बिहेवियर में होता है. सो अगर आपको वो एनालॉग इमेज को कन्वर्ट करना है डिजिटल इमेज में, सो यू हैव टू गेट दैट इंफॉर्मेशन फ्रॉम द एम्पलीट्यूड एंड द स्पाइरल बिहेवियर. स्पाइरल बिहेवियर मतलब कुछ भी नहीं, द स्पेस रिलेटेड बिहेवियर. Okay, now the digital image, if I want to get it, then obviously I have to convert the continuously sensed data into a digital format. So what are the ways of doing it? This process has two steps to it. One is sampling and second one is quantization. Now image is continuous with respect to x and y coordinates and it is also continuous in the amplitude. So you have to sample both the things. Okay, so digitization has to be done for both the things. It has to be done for your coordinate values. See, we are dealing with 2D images. So we are dealing with which coordinate values? Obviously only x and y coordinate values. So जब मैं coordinate values, that is x and y coordinate values का digitization करूँ, that is the process which is called as sampling. That is the process which is called as what? Sampling. And when I am digitizing the amplitude, then it is called as quantization. Okay, so I hope the basic meaning of sampling and quantization is very clear. The digitization of the coordinate values is called as sampling, whereas digitization of the amplitude values is called as quantization. In simple words, very basic concept. Okay, now suppose that there is a continuous image along a line segment AB. To sample this function, what we do is we take equally spaced samples along the line AB. The location of each sample is given by a vertical tick mark. So for example, this is a line and I take samples like this. Equally distance. अब जितने ज़्यादा samples लोगे उतना अच्छा image मिलेगा. जितने कम samples लोगे उतना you will get a lower quality image. Okay. So, in order to form a digital image, the gray level values must also be converted or quantized into discrete quantities. See, till now I was talking about sampling. But आपका जो amplitude है, आपका जो gray level values है, जो भी continuous form में है, उसको भी sample करना पड़ेगा. So we can, let us say that we can divide a grayscale into 8 discrete levels from black to white. I told you initially, black color, white color. सिर्फ ये 2 ही कलर्स है इमेज में, then it is a black and white image. ग्रे स्केल इमेज मतलब कौन सा इमेज जिसमें ब्लैक भी है, व्हाइट भी है, बट बीच में ग्रे लेवल्स भी है. अभी कितने ग्रे लेवल्स है ये डिपेंड करता है आपके इमेज के टाइप पे. ओके, सो बेसिकली व्हाट वी डू इज वी ट्राई टू क्वांटाइज these amplitude values also. So you can decide how many colors you want to have in your image. So suppose I decide that 8 discrete levels will be there from black color to white color. Okay, so vertical tick marks again are used to assign the 8 levels. So the continuous gray levels are quantized by simply assigning one of the 8 discrete gray levels to each sample. Okay, and how do we assign it? ओरिजिनल जो भी कंटिन्यूअस ग्रे लेवल है उसके सबसे नियर बाय जो वैल्यू होगा, वॉट एवर इज द वर्टिकल प्रॉक्सिमिटी फॉर इट. प्रॉक्सिमिटी इज नियरनेस. प्रॉक्सिमिटी इज नियरनेस. ओके, ऑफ टिक मार्क का सपोज योर ग्रे लेवल इज हियर एंड द टिक मार्क इज हियर. सो दिस ग्रे लेवल इज इन प्रॉक्सिमिटी ऑफ दिस. सो ये आपका ग्रे लेवल है. आपका एक टिक मार्क यहाँ पर है, एक टिक मार्क यहाँ पर है. Now tell me, this distance is less or this distance is less? Obviously this distance is less. So this gray level may be assigned this particular value. Understood? So this is how sampling is done. X and Y values are sampled, and in quantization, as I told you, vertical sampling is done. So what you get is this. जब sampling and quantization complete होता है, आपको ऐसा image मिलता है. Understood? So you can see the shape is not exact, and the colors are also not exact. The reason is we have performed sampling. Abhi, instead of 8 gray levels, if I consider 16 gray levels, then the colors will be more matching. If I consider 32 gray levels, the colors will be even more matching. So आपका sampling जितना नजदीक नजदीक होगा, उतना अच्छा precision आपको मिलेगा. Okay? Now, what is a digital image? A digital image can be expressed as f of m comma n. You can see the brackets. Okay, square brackets are used. It is described in a discrete space, which is derived from the analog image f of x comma y. Dot hai, but it is actually comma over here. Okay, so f of x comma y is nothing but your image in a continuous space. आप सैम्पलिंग करते हो, क्वांटाइजेशन करते हो, आपको क्या मिलता है? f of m comma n in square brackets. Okay, so what we are doing basically is you take the continuous image, you divide that in rows and columns. You are getting it? So your m value goes from 0 to m minus 1 and n value goes from 0 to n minus 1. Okay, I hope this part is very simple and very clear.